Okay, good morning, everybody. What I wanted to do first of all was just very quickly show you the upcoming Forsyth talks that we're doing. Today's is on planning power for power, and then we're also going to talk about why it's time to transition to Power 8. But I also wanted to show you that April 16th we have Charlie talking on I/O and local disk configurations for the new Power 8 big servers. I'm going to talk on VIO server maintenance in May, and Charlie's going to talk about HMC version 8 templates in June. You'll see a lot of TBDs here, so what I've been doing is asking people to send me subjects that they would be interested in hearing us speak on, rather than having us just randomly pick topics. And also down the bottom of this link, you'll also find links to the articles that Charlie and I have written, and also Ed, as well as links to the virtual user groups. Additionally, we have our movie site, and at this point, all the presentations I've given are finally uploaded. So I'm sorry it took so long, but the ones from November on live petition mobility, the VIO server maintenance ones, I have finally uploaded those to YouTube. So if you want to listen to the replays, you can. So I just wanted to give you that option. And then the last thing I wanted to mention was that IBM has changed their conference schedule, and now the big conference that is typically run in October is going to be run as part of the EDGE conference in May. So if you typically go to the Power conference in October, you want to get yourself to the one in May, which is May 11 through 15 at the Venetian. And if you go to ibm.com/edge, it will take you through. There's the agenda. More importantly, early registration, you get a discount until April 5th. So I just wanted to bring that up so that nobody misses that opportunity. The topics we're going to cover today are about power for power. One of the things that I get asked all the time by customers and by vendors is, why do we have to have so many PDUs? I'm measuring my power and I'm not using anything like you're telling me, so I want to plan to put more things on my PDUs. So that's one of the reasons that we're going to talk about this, is to understand what the requirements are for electrical power and why they seem so bizarre. So as part of that, we'll go through some terminology, we'll talk about PDUs and line cords, we'll talk about architecting for power, and then I'll use some examples to show you how we come to these conclusions. And then the second presentation is a lot shorter, and it's just really talking about Power 8 and why it's time to consider migrating to Power 8. And both of these, there's articles in the most recent IBM system magazines that you can read that kind of back up what I'm talking about here. So the issue with PDUs and power is that servers are more powerful and they draw more power. As you go from Power 6 to Power 7 to Power 8, you need more amperage to drive those servers, even though the servers are so significantly more powerful. There are also rules about PDUs and how to plan for power, but they're incredibly confusing, because I'll tell you that you need, let's say, 3.6 kVA, but you need 3.6 kVA on each of two PDUs, even though the server maximum draw is 3.6 kVA. And you're like, well, why do I have to do that? And so we're going to talk about how redundant power really works. And this is all part of the why can't I plan for just what I'm using? Why does IBM require so many PDUs and so on? And a lot of this actually has to do with the laws that are in place as well. So we're going to start with some terminology about power. And my husband is a physicist. His favorite joke is, what's a unit of power? And you sort of look at him blankly and then you go, oh, okay, watts is actually a unit of power. 1 watt is defined as the current flow of 1 amp with the voltage of 1 volt. So rather than try to calculate, basically you go to the IBM Red Book, the technical overview, and they tell you how many watts that server can pull. And that's a maximum if it was fully loaded. But what I always tell people to do is plan for that maximum, because as you add cards or as the server gets busier, you run the risk of actually using that maximum. Volts is a measure of the strength of the electrical source at a given amperage. So if you want to relate it to something fairly similar, it's like water pressure in a pipe. And amperes or amps is the measure of the total electrical current that can flow. So think of If you think of volts as water pressure in a pipe, think of amps as the water current. Kilovolt amps is 1,000 volt amps, and that's actually what we use for electrical circuits. So you'll hear people talk about a PDU being a 4.8 kVA or a 4.6 kVA or a 9.2 kVA and so on. And they are typically used with alternating current power, which is what we use in the United States. And then we have the BTUs, or British Thermal Units, and this is basically the amount of energy that we need to cool or heat a pound of water by 1 degree. So when you talk to your cooling people in the data center, they want to know BTUs because they need to look at the UPS to make sure they have sufficient BTUs to be able to cool the server that you're adding. So there are a whole bunch of formulas for this stuff. I'll show you. This is the first one that I have there, the electrical toolbox. If you really want to get into actually calculating these, it has all the AC, DC, direct current, one-phase, three-phase, how you actually calculate amps when you know kVA, amps when you know kilowatts. Most of this stuff I've put into a spreadsheet so that I can calculate it myself. Also, you have to think about things like what the actual voltage is. So if I show you my spreadsheet that I use, let me grab that. In the spreadsheet, I track the numbers I calculate amps depending on whether it's 200 volts, 208 volts, or 220 volts. And you can see that they're quite different. You know, it ranges from 3.01 to 3.32 depending on the actual voltage. So you do need to know the voltage, or you can just simply say, I'll use the one that's the highest. So maybe I'll use the 200 volt number for my calculations because I know I'm never going to exceed that. But if you know that your power is 208 or 220, then use the real number. There's also this rapidtables.com, and what they have there is just like descriptions of what things mean. So this is the one for amps. You can see they have a whole bunch of, more than you would ever care to know about the different electrical settings. But it is good to have this information because at some point you may be talking to the physical plant people and having conversations about these. I've got the formulas here that are pretty basic. There is something called a power factor that you do have to take into account, which I do use in my calculations, and that is you never ever get 100% of the power that you would expect to get, and that's because you lose some due to reactance in the circuits. For a power server, depending on which one, it's between 0.95 and 0.98. So I usually build that into my calculations in the spreadsheet for working out some of the voltages and so on. So you'll see here that where you'd use a power factor is when you're actually calculating kilovolt amps. If they give you the amps and the voltage, and you're doing three-phase, then you use a power factor. Most of you will be doing single-phase, so it shouldn't be an issue. In the IBM environment, we have some specific IBM PDUs and line cords, and I'm going to speak to those. But if you're using third-party PDUs and line cords, you can simply translate those. So the first thing is there is a National Electrical Code, and in the U.S., under that National Electrical Code, we are required to derate our PDUs. What does that mean? It means when you think you have a 60-amp PDU, well, first of all, the PDUs are actually all identical. They can be 30, 60, or I think 120 amps. It depends on the line cord. If you attach a three-phase line cord with certain things, you can get 19.2 kVA. If you have a 60-amp line cord, then you get 9.6 or 48 amps. So basically, if you have a 60-amp PDU, you are required to derate it to 48 amps. What that means is you can never commit to putting more than 48 amps or 9.6 kVA on that PDU. That's US law. And on top of that, the reason that they did it was because they had some fires because people overcommitted PDUs. And then for a 30-amp PDU, you can't plan for more than 24 amps or 4.8 kVA. So those are your planning points, and that's what I build into my planning spreadsheets when I plan for PDUs. The IBM PDUs come in two flavors. There's the 9188, 7188. Those are feature codes, and that's just a regular PDU. And it can handle, as I said, the 30, 60, or it can actually take a three-phase input. The 5889, 7109 is the intelligent PDU with monitoring capabilities. All that means is it can report on what it's using. Each one of these PDUs has 6 pairs, so 12 total of IEC 320 C13 outlets, and they basically serve out 200 to 240 volts. And each of those outlets is rated at 10 amps. But each of the pairs has a circuit breaker for 20 amps, which of course gets derated to 16 amps on the 7180, is a typo there, and 15 amps on the 5889 7109 pair. Therefore, you can't basically commit to more than around 16 amps on a pair. Very bizarre. So the full amperage for the PDU is either going to be 16, 24, or 48 amps, depending on what you actually have for a line cord. And the line cords that I typically see in the US are the 6654, which is known as an L630P, which is a 30 amp line cord, so it would be derated to 24, or a 6492, which is a 60 amp IEC 309 derated to 48. And more, we're trying to get people to go with the 60 amp line cords, because otherwise, and you'll see when I show you some of the Power 8 numbers, what we're seeing is that people are having to have a lot more PDUs, and it gets very, very frustrating. All right, so this is right out of the Red Book, where it actually says that, we have these 620 amp circuit breakers, and basically the different line cords and what they can handle. So you can see this is the three-phase one up the top here, and it can handle up to 21 kVAs. But the 6492 is your 9.6, and your 6654 is your 4.8. So it's probably better to do the sizing in kVAs. Then there's a whole bunch of other ones depending on whether you want to have special connectors and plugs and so on. So that's how you do the basic sizing. And then, as I said here, the total power load connected to any C13 outlet must be limited to 10 amps. And that's one of the reasons why you'll see with the S824 and the E870, they now have 4 power plugs instead of 2, because the E870 pulls 19 amps. Well, you can't plug that into one 10 amp plug. So what you do with the E870 is you take those 2 plugs and you put them into 2 separate pairs on the same PDU, and now you're inside of the rules. This is actually what the PDU looks like. So these are each 10 amps. And these are each 10 amps with the circuit breaker. Interestingly enough, I have actually had servers go down because people actually plugged the server into the first socket, then a new I/O draw came in and they plugged it into the second one, and everything was going fine until the server got really busy, and what happened was it started to pull enough amps to take the circuit breaker, and that took everything down. So that's one of the reasons it's very, very important to pay attention to what is plugged in where and how often. These are pictures of the actual plugs for that 6492, 60 amp, and 6654. I get asked all the time by electricians, well, what's the receptacle, what's the connector type? This has all that information in here. So it's quite a useful little picture. So let's talk about how we architect for this, right? I've given you some of the basics. And a lot of the confusion is due to the way redundant power supplies work. Because if I tell you that my 824 is rated at 2.38 kVA, which is around 11 amps. I've got 4 power cords, 2 pair that are the live ones and 2 that are redundant. So we take 2 cords to one PDU and 2 to a second PDU. What I'm telling you is you actually have to plan as if you were going to be using twice the kVA, twice the amps. The reason for that is, let's say we're currently using PDU 1 and we're pulling our 2.38 kVA. Circuit fails, or the PDU fails, or the power supply fails. Now suddenly we flip over to the second PDU. Well, if you architected that second PDU so that it was full and it was just a failover for this one, then you've got a serious problem, because now that PDU is going to fail because you've overloaded it. Or you could cause a circuit breaker to go, or other things could happen. So because we have, A, no control over which PDU it draws from at any time, and secondly, if a PDU fails, it will draw from the other PDU, we have to plan out as if we were going to be using full power on both PDUs at the same time. So that's one of the reasons why, even though you say to me, well, I'm only really drawing 2 kVA, but you're making me plan for 2.38, and you're making me plan for it on each of 2 PDUs, that is the reason why. Because if you overcommit, assuming that a PDU or a circuit will never fail, you run the risk of an outage. Additionally, we don't actually know which PDU it's going to draw from. So that's the rationale behind that. And that is actually, and so planning it that way and using the numbers that I'll show you in a few minutes is actually a requirement. And if you don't do it, you can end up in an unsupported position. Plus, if you overcommit your PDUs and the outage causes damage to a circuit board, I wouldn't want to guarantee that you might not end up paying for the repairs. So just be very aware that it's much better to plan for more PDUs than it is to have to pay to fix it later. And the kVA watts BTUs I use are the ones listed in the Red Book. So for every server I have, I download the technical overview and introduction for that server, and I get the numbers from there. And the reason I use maximums is if I add cards later or the server gets busy, then I don't have any risks out there. And PDUs just aren't that expensive. I realize electrical circuits are, but just keep that in mind. So here's an example of an S824. So here's my two power supplies that we'll call these the live ones. They're going over to PDU1, and they're going to pull somewhere around 11.9 amps or 2.38 kVA. And then here's my redundant pair to another PDU, and they're going to pull the same amount. Obviously, only two of these are working at a time, but like I said, we don't know which two. But it just gives you an idea. And all the other servers except the E870 are going to be one power plug going each way. It's just because of the amount of kVA and amps this pulls. Clearly, since I have a 10 amp limit on each plug, I can't put just one plug over there. It has to be two. So hopefully this is making sense. So this is right out of the Red Book. I put the actual full link down here. This is the technical overview for the 824. And so what this is showing you is the operating environment. And the things we're looking for here, this is the 814, this is the 824. So the operating voltage is 900 watts of power, but the maximum is 2300 watts. So I plan on the 2300. I use the 2.38 kVA here and the 7848 BTUs per hour. Those are my planning numbers. If I know watts and kVA, I can actually calculate amps, but realistically, you could just plan your PDUs using kVA, because we already know that the limit is 4.8 on a L630P or 9.6 on a 60 amp. And if you look at the back of the 824, and I'm sorry, this is a really fuzzy picture, you'll see where the four power cords go. So I believe these two go together and these two go together. And if you only have a one-socket system, you do only have to use two power supplies. If you have a two-socket system, which is what most people buy with the 824, then you have to use all four power supplies. Now for the E870 and E880, their operating environment is a lot higher than people expected. Each enclosure is 4.2 kVA. So right there, if you have a 30 amp PDU, which is rated at 4.8 kVA, right there you can see that you can only connect one E870 or E880 enclosure per PDU. So if you end up with a two-node 870, you're going to need 4 PDUs just to support the 870, and you could probably throw the HMC on there as well, but that's it, because that's going to be 8.4 kVA plus the HMC and so on. So if you go with an E880 and later this year you go to 4 nodes on it, you're going to need a lot of PDUs. And this is one of the reasons why we're recommending that people start to seriously think about moving to the 60 amp PDUs, which at least can handle 9.6 kVA. And again, basically what I do is I go to the Red Book and then I just do a search on watts or kVA, and it brings me down to this section, which is always under operating environment. So for power planning for an 870 and 880, it requires 4 AC power supplies for each system node enclosure, and that's a 2+2 redundant. And the reason for that, as I said before, is because the E870 is around 19 amps or 4.2 kVA, and clearly, since each pair of plugs has a 20 amp circuit, and has a 10 amp per plug, we obviously, if we're going to be pulling 19 amps, then we need to split that across not just 2 plugs, but across 2 of the circuits in the PDU. So you cannot plug a pair of AC power supplies into the same pair of plugs on the PDU. Right? They have to be on different spots on the PDU. The actual system control unit is powered from the system node, so it does not need its own power supply. The only time you need to provide power for the system control unit is if you add the DVD. And if you add the DVD, there's a couple of special power cords that we add. But that's very, very minimal relative to the 4.2 amps that the actual 870, 880 pull. So this is one of the reasons we're having the conversation, is that with Power 8 becoming so incredibly powerful, it's drawing more power, and we need to be able to plan for that. And this is basically reiterating what I just said, that with the E870, 880, and even the S824 requiring more power, because the S824 is around 11 amps per server, we really need to start considering going to the larger PDUs. Well, actually, the larger line cords. So just to compare the 870, 880 to the 770 and 780D models, you could see that we've gone from about 1.6.5 to 2 kVA right up to 4.2. I forgot to put the RPERF in here to show you the performance differences, but that's obviously significant. So you're getting an awful lot more performance, but obviously you've got more of a power draw and more of a heat and cooling issue. I've just put in the weight and the IO draw and so on, and some of the physical requirements like a 2-node with SCUs, 12U, and if you need internal disks, you have to add a special expansion draw for those. So the key thing to note is that if you go with the 60 amp PDU, I can basically support 2 nodes and an expansion draw with 2 PDUs. If I stick with L630P, I can only support 1 node and 1 expansion draw per PDU. Again, I've got a bunch of examples here. So here I have an S824 and a 3-node 770D and an HMC and monitor. So each 770 node requires 1.649 kVA, and I have 3 of them, so it's 4.947. The S824 is 2.38, and the HMC is 0.55. The monitor is minimal, so I include that in the HMC. Each one has redundant power plugs. Basically, it comes up to close to 7.9 kVA. So on a 30 amp, I only have 4.8 kVA per PDU pair. So I would need 4 PDUs for this. And I would have to split the things across the 4 PDUs to make sure that I didn't overcommit any PDU. This is just showing you that spreadsheet that I was using, and I just published it for the 220 amps. So here you can see the different ratings for like an HMC, which is 0.7 kVA, 3.18 amps, and these are guesstimates based on calculation. So if I was on an L630P 30 amp, I could put 6 HMCs on it. I could put 7 710B models, but I can only put 2 780Ds on it. All right, and I've got the IO draw information here as well. So that's per PDU pair. So if I was to do a 780D, I could put 2 nodes across. 2 nodes across 2 PDUs. All right, then I have the same for L630 over here, which is for the 60 amp over here, and it's 4. So you've got to look the numbers there. For the Power 8, here you can see the 824 and the similar numbers. So just to give you a feel so you can throw it into a spreadsheet for each PDU and calculate it, and then just go, okay, I need that many PDUs times 2. So I have a spreadsheet that I do this in. So here I have, and this was using 208 volts. I have 2 822s and an HMC, so I was planning the amperage for them, and I used amps instead of kVAs. So my first box, here's its primary and secondary. The second box, here's its primary and redundant. And I literally had each of the plugs labeled, and my HMC and my monitor, and then the HMC, the monitor's single power. So then I add up my amps to make sure that I'm not hitting my 24. This is a smart thing to do. Your physical plant people are probably doing it, but it's a good thing to know, what you're doing, because I've had a lot of customers that no one's been really tracking this stuff, and suddenly they added one thing and took everything down. This is just showing you with a bunch more of them in here on a 60 amp how much more I can get in. I can actually get 5 822s in my HMC. And then I've got examples, which I didn't put in here, of like 824s and E870s, just to give you a feel for the differences. So how do we avoid problems and not get into this situation? So the first thing is we plan for power before ordering anything. One of the requirements for Power 7770s, E870s, E880s and above is that we have this thing called a mandatory TDA, which is a technical delivery assurance. It used to be called a solutions assurance. Any business partner or IBMer should be doing this with you if you're ordering these large boxes. They're also required for first and enterprise, so if you get your first Power 8, we should be doing what I call a mini TDA. And I basically do them for everything anyway, because in my view, all the issues that I've ever run into come down to, in certain cases, weight, if you're going with like a 795. Power is always one, and also network and fiber cards, because network cards come in so many different flavors, from 1 gig E to 10 gig E copper, 10 gig E fiber, and so on. So making sure that those are correct before any kind of an order is placed is just beneficial to everybody. And going through this TDA and talking through power issues can stop a lot of problems from happening. And so typically we do like a summary of the configuration, items that we need to confirm, is there a way to get the box into the elevator and so on. We talk through power and cooling requirements. There's some pre-sales and pre-install checklists which have to do with operating system versions and so on, reference information, and then it may also include things like LPAR layouts and memory overhead. If you actually have the information on how you want your LPAR set up, that can be included. But really the purpose of that TDA is to make sure that everything goes smoothly and there's no problems with power, rack space, Ethernet, and HBA types. It is the best 60 or so minutes that you can spend, because it can save you hours later from having to redo things. So if you're not getting those, then you should request them before the order gets placed. You should be getting them, but I'm just recommending that. And as I said, for the 770, 870, and 880, they are mandatory anyway. And now I have a bunch of different references for you. There's this is the link to the article on power. These are those power formulas. Quail.com actually has some pictures of the power cords, and then IBM has their supported PDU power cords and so on. You can also use the IBM Systems Energy Estimator. The problem with the Systems Energy Estimator is it estimates what you're going to use, but as I said, you're actually required to plan for the maximum kVAs that they publish. So this gives you an idea of what you'll use, but you actually really need to plan for the full potential. I really hope you guys found this useful. Please send me an email if you have any questions. Hopefully it isn't too confusing.